Hello, and welcome to ADHD Focus and Motivation. If you're fascinated by the intricacies of the human mind, particularly ADHD, you're in the right place. Today, we're embarking on an extensive exploration into the groundbreaking discoveries in ADHD research. Prepare to dive deep into the world of neuroscience, genetics, and psychology as we unveil the science behind ADHD. Let's start by delving into what ADHD truly is. Attention Deficit Hyperactivity Disorder, commonly known as ADHD, is a neurological condition characterized by a distinct set of behaviors, including difficulty in maintaining attention, hyperactivity, and impulsiveness. But what's beneath these behaviors? Recent studies suggest it's a complex interplay of various factors like genetics, brain structure, and environmental elements. We'll explore how these factors influence behavior, why ADHD manifests differently in individuals, and the common misconceptions surrounding it. By understanding these elements, we unravel the complexity of ADHD, paving the way for better management and acceptance. Starting with genetics, the hereditary aspect of ADHD has long intrigued scientists. Recent advancements in genetic research have identified specific genes that contribute to ADHD. These discoveries are vital as they not only demystify the hereditary patterns of ADHD, but also assist in developing targeted treatment plans. We'll examine the significant genetic markers identified, understand how these genes influence ADHD, and discuss the potential for future genetic therapies. Researchers have identified several genetic markers linked to ADHD. These include genes like DRD4 and DAT1, which are involved in dopamine regulation, and other genes related to neurotransmitter systems. Studies have shown that variations in these genes can influence the likelihood of developing ADHD. For instance, certain variants of the DRD4 gene are more common in individuals with ADHD, suggesting a direct genetic link. The genes identified, such as DRD4 and DAT1, play a crucial role in the dopamine pathways of the brain. Dopamine is a neurotransmitter that's integral to regulating attention, motivation, and pleasure. Variations in these genes can lead to imbalances in dopamine levels, which are thought to contribute to ADHD symptoms. Besides dopamine, other neurotransmitters like norepinephrine and serotonin are also involved in ADHD. Genetic variations can affect the functioning of these neurotransmitters, influencing attention, impulsivity, and hyperactivity. Understanding these genetic markers opens the door to personalized medicine. In the future, treatments for ADHD could be tailored based on an individual's genetic profile, potentially improving effectiveness and reducing side effects. There is ongoing research into gene therapy as a potential treatment for ADHD. By targeting the specific genetic variations associated with ADHD, gene therapy could offer a more direct approach to managing the condition. However, this is still in the early stages of research and requires further development and testing. While the potential for genetic therapies is exciting, it also raises ethical questions about genetic manipulation and the implications of altering human genetics. There's also the challenge of ensuring that such treatments are accessible and affordable for all individuals with ADHD, avoiding disparities in healthcare. The identification of genetic markers related to ADHD is a groundbreaking step in understanding and potentially treating the disorder. As research progresses, the hope is that these findings will lead to more effective and personalized interventions. Although this must be balanced with ethical and practical considerations. Brain imaging technologies like functional magnetic resonance imaging (fMRI) have been pivotal in ADHD research. These techniques reveal how the ADHD brain differs structurally and functionally from non-ADHD brains. Key areas like the prefrontal cortex, which plays a critical role in focus and decision-making, show unique activity patterns in those with ADHD. We will delve into these brain imaging studies, examining what they reveal about ADHD brain functioning and the potential implications for treatment and understanding of the disorder. Brain imaging technologies, especially functional magnetic resonance imaging (fMRI), have revolutionized our understanding of ADHD. fMRI allows researchers to observe brain activity in real time by detecting changes in blood flow associated with neural activity. fMRI studies have provided critical insights into how the brains of individuals with ADHD differ from those without the disorder. For example, differences have been observed in the activation levels of certain brain regions, such as the prefrontal cortex, which is essential for attention, planning, and impulse control. These studies have also shown variations in brain connectivity and network activation, suggesting that ADHD may involve broader network dysfunction rather than isolated issues in specific brain areas. fMRI has been instrumental in evaluating the effectiveness of ADHD medications and behavioral interventions. By observing how these treatments alter brain activity, researchers can better understand their mechanisms and improve treatment strategies. For instance, fMRI studies have shown that stimulant medications commonly used to treat ADHD can normalize activity in key brain regions, supporting their therapeutic benefit. One promising area of research is the development of biomarkers for ADHD using fMRI data. Biomarkers could aid in the early diagnosis and prediction of treatment response, making it a valuable tool in personalized medicine approaches. While fMRI has provided substantial insights, it also comes with limitations. fMRI data is complex and can be influenced by various factors, requiring careful interpretation. Future research aims to combine fMRI data with other modalities, like genetic and behavioral data, to develop a more comprehensive understanding of ADHD. Brain imaging technologies, particularly fMRI, have been pivotal in advancing our understanding of ADHD. These technologies have not only revealed key differences in the ADHD brain, but also opened up new avenues for treatment evaluation and the potential development of biomarkers. As research continues, fMRI is expected to remain an integral tool in unraveling the complexities of ADHD. The environment is a significant player in the development and expression of ADHD. Factors ranging from prenatal conditions to early childhood experiences have profound impacts. We'll investigate how environmental factors like diet, upbringing, and exposure to toxins correlate with ADHD. By understanding these environmental influences, we can better grasp the complexity of ADHD and consider holistic approaches in its management. Environmental factors play a crucial role in the development and expression of ADHD. While genetics set the stage, the environment can significantly influence the severity and manifestation of ADHD symptoms. Diet and nutrition are increasingly recognized for their impact on ADHD. Studies suggest that certain dietary patterns, such as high sugar intake, may exacerbate ADHD symptoms. Conversely, diets rich in omega-3 fatty acids, found in fish and some nuts, have been associated with reduced symptoms, possibly due to their role in brain development and function. There is also research exploring the role of food additives and preservatives in ADHD, although the evidence is mixed. The social and familial environment during early childhood is critical for cognitive and emotional development. Stressful or unstable home environments, inconsistent parenting styles, and lack of mental stimulation can contribute to the development or worsening of ADHD symptoms. Positive environmental factors, such as supportive parenting, structured routines, and educational support, can help mitigate ADHD symptoms and improve outcomes. Exposure to environmental toxins, particularly in early development stages, has been linked to an increased risk of ADHD. For example, lead, commonly found in old paint and plumbing materials, has been significantly associated with ADHD symptoms. Prenatal exposure to tobacco smoke and alcohol is also linked to a higher risk of ADHD in children. Emerging research is exploring the impact of other pollutants, like pesticides and phthalates, on ADHD prevalence and severity. It is important to note that environmental factors often interact with genetic predispositions. This interaction can influence the likelihood and severity of ADHD, highlighting the complex nature of the disorder. Environmental factors such as diet, upbringing, and exposure to toxins play a significant role in the development and expression of ADHD. These factors can interact with genetic predispositions, underscoring the multifaceted nature of the disorder. Understanding and addressing these environmental aspects can be crucial in managing ADHD effectively. Effectively managing ADHD is a multifaceted challenge. It involves a combination of medication, behavioral therapy, and lifestyle adjustments. But there's more to it. Recent developments have introduced innovative management techniques, including neurofeedback and mindfulness-based therapies. We'll examine these strategies in detail, discussing their effectiveness, applicability, and how they can be integrated into daily life for those with ADHD. Traditional ADHD management often involves medication and behavioral therapy. However, recent years have seen the emergence of innovative techniques like neurofeedback and mindfulness-based therapies. These methods offer alternative or complementary approaches to traditional treatments, focusing on brain training and mental awareness. Neurofeedback, a type of biofeedback, uses real-time displays of brain activity, typically through EEG, to teach self-regulation of brain functions. In ADHD management, neurofeedback targets brain regions implicated in the disorder, such as those responsible for attention and impulse control. Patients learn to modulate their brain activity, aiming to enhance concentration and reduce hyperactivity and impulsiveness. Studies have shown that neurofeedback can lead to improvements in attention, behavior, and cognitive function in individuals with ADHD. These benefits may persist even after treatment ends, suggesting lasting changes in brain activity. Mindfulness-based therapies involve practices that encourage heightened awareness of the present moment, typically through meditation and focused attention exercises. For ADHD, mindfulness practices are designed to improve concentration, reduce impulsivity, and manage stress. This approach helps individuals become more aware of their thoughts and behaviors, which can lead to better control over ADHD symptoms. Research indicates that mindfulness can improve attention, reduce anxiety and depressive symptoms, and enhance emotional regulation in people with ADHD. It also promotes overall well-being and stress management, which are crucial for managing ADHD. Neurofeedback and mindfulness-based therapies can be used in conjunction with traditional ADHD treatments like medication and behavioral therapy. This integrative approach allows for a more holistic management of the disorder. By combining these innovative techniques with traditional methods, patients may achieve better outcomes, including reduced reliance on medication and improved overall functioning. Ongoing research continues to refine these techniques and evaluate their long-term efficacy. Future developments may include more personalized neurofeedback protocols and the integration of mindfulness practices into routine ADHD care. Neurofeedback and mindfulness-based therapies represent exciting advancements in ADHD management. These innovative techniques focus on training the brain and enhancing mental awareness, offering new avenues for treatment that complement traditional methods. As research evolves, these approaches may become integral parts of comprehensive ADHD management strategies. ADHD is not just about challenges. It's also about unique strengths and abilities. Studies show that individuals with ADHD often display remarkable creativity, resilience, and an ability to think outside the box. The research on ADHD is ever evolving, with new discoveries on the horizon that could revolutionize our understanding and treatment of the disorder. We've explored these upcoming research areas, including potential breakthroughs in genetic therapy, advanced brain imaging techniques, and novel psychological interventions. We'll continue to discuss what these developments might mean for the future of ADHD treatment and understanding, highlighting the exciting possibilities ahead. Thank you for joining us on this comprehensive journey through the science of ADHD. Our aim is to empower you with knowledge and understanding, especially when it comes to navigating the complexities of ADHD. Remember to hit like, subscribe, and share this video for more in-depth content. Stay curious, focused, and motivated.